This video is going to discuss some of the reactions which acids do with other compounds. The first example we're going to do is how an acid reacts with a metal. So we're going to use hydrochloric acid, which is a strong acid, plus some sort of metal. Now the metal has to be somewhat active. That is to say, one of the metals close to the left on the periodic table. The group 1As are very reactive. They'll even react with water. The second column, metals will react with strong acids, but not water so much. So magnesium metal will react with hydrochloric acid. And this is a redox reaction where the H plus gets converted to H2 gas. And so if it's H plus here and neutral here, it has gained an electron. So hydrogen is gaining. That's reduction. Okay, so the hydrogen gets reduced. And so that means the magnesium gets oxidized. Now magnesium will make a +2 cation salt. And, and of course to get 2 hydrogen, we need to have a balanced chemical reaction. So it turns out that magnesium, since it's going to lose 2 electrons to be oxidized to Mg2+, well, you need 2 H pluses to accept those 2 electrons. And so this is, the element is the metal being replaced by hydrogen. Okay, the next reaction we're going to talk about is the reaction of an acid with a hydroxide type base. And in this example, I'm going to use acetic acid, which there's many different ways of writing it. But if it's written this way, the hydrogen that's on the carboxylic acid group is the acidic hydrogen. That's why it's called carboxylic acid. And so there's only one acidic proton, not these 3, just this one. Sodium hydroxide. These are both aqueous. The H plus and the OH minus combine to make water. So you may have heard an expression, an acid plus a base gives a salt plus water. Well, the water is from H plus and hydroxide. The salt is the 2 remaining ions, which is sodium cation combined with acetate anion. Now, in ionic compounds, generally, remember, we don't write the charges, although it's expected that we understand what the charges are. So anytime you see Na in a compound, think sodium plus 1 cation, and that means something about the other thing must be an anion with a total -1 charge. So this is sodium acetate, which is the salt. If I'd used HCl as the acid, then I'd gotten table salt, sodium chloride, as the salt. The point being here that the essence of the acid-base reaction in this case is H plus, OH minus makes water, and then the other stuff is the salt. All right, let's do another example of an acid with a carbonate. Let's do sulfuric acid. And I'm going to react it with a carbonate which already has one of the protons on it. This is baking soda, sodium hydrogen carbonate. So remember the previous video where we said carbonic acid is H2CO3 and it has 2 acidic hydrogens? Well, all we're going to do is realize this is HCO3 minus, which is carbonic acid, except it's missing a proton. Well, where's that proton going to come from? It's from sulfuric acid. So this is going to have 2 protons, only one needed for hydrogen carbonate to become bicarbonate. So we'll balance that in just a second. There's 2, and we're going to get H2CO3. Okay, so that's always the product of any sort of carbonate reacting with acid. Hydrogen carbonate only needs 1 more proton. Carbonate needs 2 more protons to make carbonic acid. All right, and so what's left over is the salt, sodium sulfate. Okay, and now we can see everything's balanced except for the fact that we have to make 2 carbonic acids to get this to balance right. Now the thing about carbonic acid is it further decomposes to water plus carbon dioxide. All right, and so carbonic acid is a particularly important component of our body because respiration produces carbon dioxide, and that can build up in the body, which of course forms carbonic acid. And the carbonic acid will affect the pH of the blood. Okay, and and of course we'll need two of each, right? One carbonic acid goes to water plus CO2. So one way to write the chemical reaction of a carbonate with an acid is to form carbon dioxide and water instead of saying carbonic acid. The last reaction is going to be the reaction of an acid with an amine, and we're going to do nitric acid, just to choose a different acid. And that's going to be, in essence, the proton goes onto the nitrogen to make what's called a quaternary nitrogen, a nitrogen with 4 bonds to it, and it'll have a positive charge. So it'll be the ammonium cation, NH4+, but it'll be part of the salt, which is formed from nitrate and ammonium, which is ammonium nitrate. That's a substance used in fertilizer, but you can see there is no water produced by this chemical reaction.